So we're going to continue 1-3 today. Yesterday we talked about domain and range from a graph, right? Left to right is your domain, bottom to top is your range. And then we talked about, what else we talked about yesterday? Oh, evaluating a function. So if I gave you the x, you had to give me the y to match it. So today we're going to pick up with what's called the vertical line test. In 1.2, we learned two ways to identify if something was a function. One was based on its points, and one was based on the equation. Now we're talking based on a graph. So you use the vertical line test to determine if the graph is a function. If the vertical line hits the graph at more than 1 point, then the graph is not a function. So example 2 says use the vertical line test to determine whether the curve is the graph of a function. If it is, state the domain and range of the function. So if we look at A, okay, you can either visualize vertical lines in your head or you could literally draw your vertical lines. If any single vertical line hits your graph at more than 1 point in any of them, then it's a no. So this one hits it here, hits it here, hits it here, hits it here, hits it here. Do any of those, or any other ones we could draw in between, intersect your graph at more than 1 point? No, so this is a function, okay? So the second part of the instruction said if it is a function, find domain and range. Good question. So if I go furthest point left to furthest point right, that's my domain, which in this case would be what?
0, 4.
Good. 0 to 4, brackets or parentheses? Brackets. Those are solid points, so they both get the brackets. And then range, we're going bottom to top, right? So lowest y to highest y, which would be 0 to 3. Brackets or parentheses? Brackets. Good. Questions on that one? Okay, B says, again, start the same way. Vertical lines. Do any of the vertical lines intersect this graph at more than 1 point? Yep, all of them do, except for the very left and the very right, right? So this is not a function. So overlap this with what we did in 1-2 and think about what's happening, right? If I give you a set of points, when was it not a function? Other way around, right? When one x has a different y, right? The same x is repeated with a different y. So if you think about if x is 0, right? Look at these 2 points, for example. This is 0, 4, and this is 0, negative 4. That same x is repeating with a different y. So if you looked at points, it should rule it out, right? And then if you're looking at an equation, what would make it a no? Absolute value on the y, or? Y is raised to an even power. This is an ellipse, right? That's what that's called, that oval shape. And in an ellipse, the x and the y are both squared. So if you had the equation of this graph, you would have also ruled it out because of that. So it's consistent across the board. Whether you're looking at the points, you're looking at the equation, or you're looking at the graph, it's always a yes or it's always a no. All right, finding the zeros of the function. So if I want to find the zeros of the function, it's also called the roots of the equation. It's called the solutions to the equation, and it's called the x-intercepts. All of those are the same thing, and you'll see your book use them interchangeably. No matter which of those 4 ways it asks you to find it, you're setting your equation equal to 0. You're replacing the f of x with 0, and you're solving. There's going to be a lot of factoring involved with this stuff. So again, If factoring is something you need to focus on, if you want to spend your Labor Day weekend reviewing factoring, there's a video in the iTunes U course under 1.2 because that's when we started to bring it back in. Increasing and decreasing behavior. So when when you're asked to identify the increasing and decreasing behavior from a graph, you're going to visually move from left to right. If the graph is rising as you're moving from left to right, then it would be increasing. If it's falling, then it's decreasing. And there's a third option, which is that it's constant. So if it's horizontal, then it's constant. And you will give these answers in interval notation. I just went back to example 1 or example 2 so that we can just look at increasing, decreasing behavior here. Okay, so if you want to look back at it, that's what this is. So if I'm moving from left to right on my graph, then the first little segment before it changes direction looks like that. Is that increasing or decreasing?
Decreasing.
That's decreasing. So I'm going to say that this is decreasing on the interval, and we use the x values from 0 to 1. So this would be my 0, this would be 1, this would be 2, this would be 3, this would be 4, that's 5. So from 0 to 1, my y's are decreasing. We agree on that? Yes? Okay. Then it changes direction. It goes up, which means increasing from 1 to 2. And then changes direction again. We're back to what? Decreasing. So from 2 to 3, it's decreasing. And then the last one, increasing, changes direction again from 3 to 4. If that was an arrow on the end, it'd be from 3 to positive infinity, right? Increasing and decreasing will always use parentheses. A point itself, this dot, can be neither increasing or decreasing, right? It's a dot. It's at a standstill place. And especially if it's using, God bless you, to change direction, how could I tell you if that one was part of the increasing or the decreasing to give it a bracket? You wouldn't be able to determine that. It's the spot in which it changes direction. So you will always use parentheses on these. The exception is if it were to start or stop, constant. So this one, let's say I add on that little bracket. A point can be constant, right? So I would then say that the constant part of this graph is from 4 to 5, and the 5 gets the bracket, not the 4, because the 4 is shared by the increasing and the constant. So the only time you're going to see a bracket on increasing, decreasing behavior is if your graph starts on the left or ends on the right with constant, with a horizontal line. Make sense? Yeah? Okay. What if I asked you for the zeros of this function? Yep. X would be 1 and X would be 3. So if it asks for zeros, you can list them. If it asks for the intercepts, that's when you want to give it important format. So you would give it to me as 1, 0, and 3, 0. Good so far? Okay. Max and min. So these are relative max and relative min. A relative max is any peak in the graph. So anytime it goes up and comes back down. And relative min is any dip in the graph. Anytime it goes down and comes back up. So if my graph did something like this, okay, every time it goes up and comes back down, it's called a relative max. So there's two different kinds of max, absolute and relative. Absolute is the highest point. It goes up, it comes back down. There's only one of those, okay? But a relative max is every time there's a peak and a fall. So every time there's a peak, it's a relative max. So there would be 2 in this graph. And then let's say that this did this. There'd be 2 relative mins every time it goes down and comes back up. Good morning. Questions so far? So again, there's no limit to how many relative maxes you can have. There's no limit to how many relative mins. Absolute is one of each, but relative, you can have more than one. And you'll give these in point format so that if this is like 1, 2, this would be 1, -2. You will give your relative max and your relative min in an XY coordinate format. All right, so we're going to use the graphing calculator to graph this and then identify the relative max and the relative min. I don't know if yours has the little minus. Mine's missing it. It should be 2x squared minus 9x. Is yours missing it? Okay. So again, we'll walk through the app and we'll walk through the handheld. But by test time, you're going to have a handheld, whether it's your own or somebody's lending it to you. Somebody not in this period, but somebody that you know outside this class is lending it to you. That's up to you. Just make sure you know how to use it. All right, so we're going to hit y equals. We're going to type in our equation, which is negative 2x squared, which you can either use the squared button or you can use the caret 2. Either one works. Minus 9x. Be careful when you type in, when you have a leading negative, so that very first negative that's there has to be the negative symbol. It has to be this, not the minus symbol. The one in between doesn't matter, okay? But the one at the beginning has to. All right, then I'm going to hit graph. And it does this. Oh, but yours, let me show you. Yours was set to wait for it. Yours was set to this. Hopefully, probably from the last time. Okay, so this got cut off on the top. There's two ways to adjust this. One is simply zoom out. So if I click on zoom, I click on zoom out. I hit enter, and it's going to take me out. And that is way too far in my book. So I'm going to instead adjust my window. So I knew it just cut off a little bit at the top. So I'm going to put it back. Oh, actually, I can zoom back. I'll show you that. So let's just say I want to zoom back out. I click zoom. And I go zoom out. Nope. I wanted to zoom in. Zoom in. Okay. My window's still messed up, so I can go to window. And I would make it -10 and +10 because my x-axis was fine. My y-axis just cut off a little bit, so maybe just change that to 12. And then go back and graph, and you should be able to see your whole graph. So you're going to play with these because as we change functions, you're going to have to change your windows, okay? All right, so to find the max on this, it's in calc. So above the trace, second, calc, is max and min. So there's only a maximum that I see. There's no minimum. I'm going to hit max. And then I get to this. So left bound, because there can be more than one max or more than one min. Remember, it can go up and come back down and up like a roller coaster. You have to say, this is the range in which I want you to pick the max from. And if there was another one, I would then say, this is the range I want you to pick the max from. So left bound means you need to go left of the maximum point. So I'm going to arrow over till I at least get left of that maximum point. How far left? It doesn't matter as long as there's not another dip and peak, okay? So then when I get left of it, I hit equals or enter. And then it says right bound. So give it its right bound. So I go right of it and I hit enter. And then it says, are you ready for me to guess? Yeah, I am. So I hit enter again and it brings me to my max point. Notice that max point matches what we had in the graphing calculator app. So my maximum point is -2.5 and 10.125. If it terminates like that, you're going to give me the whole thing. Don't round it, okay? If it kept going on and on and on and on and on and you needed to round it, then that's fine. But for that terminates, don't round it. Cassie?
Is it okay when we do it like our numbers like I didn't get 2.25
Did you do it the way I did it?
No, but I got like 2.2 and then like a bunch of other numbers.
Even when you hit left and right? Because it should be pretty exact. All right, graphing piecewise functions. So we talked about evaluating piecewise functions the other day. Remember when a function is true for this equation based on this set of numbers and this equation based on this set of numbers. Now we're going to learn how to graph it. I'm going to show you two different ways you figure out which way works best for you, okay? So the first way is I'm going to actually graph these full graphs, ignoring the restriction at the beginning. So I would say, okay, my first one is y equals 2x plus 3. What kind of graph is that? A line, right? Yeah, not a trick question. Yeah, it's a line. Okay, so up to 3, and then my slope is up 2 and over 1, or down 2 and left 1, and then I would draw my line. And then I would do the next one. So y equals 3 minus x is the same thing as y equals negative x plus 3. Start at positive 3, down 1, right 1, or up 1, left 1. Draw myself the line. With me so far? Yeah. So then I have to pay attention to the restriction. The first one says that that line is only good for the values of x that are less than 0. So if I just gave you any coordinate grid and I said, what quadrants would be the values of x that are less than 0? You would tell me what? 3 and 4, the left sides, right? No, 2 and 3, right? 2 and 3, the left sides, right? I knew where you were going. So I'm going to go back to that part and I'm going to say, okay, it's only good. So the red one is the one we're looking at. I only want to use for when x is less than or equal to 0. Less than 0. Which means it would have an open dot there. So I'd have an open dot at 3. And less than or equal to, or less than 0 would be to the left of that point. And then I would erase out the part that I don't want. With me so far? Yes. Second part says, so for now the blue one, it says, those values are good only where x is greater than or equal to 0. So I only want to use the blue where x is greater than or equal to 0, which means, So I go to where the x is 0 and greater than is to the right. And I would go back and I would erase anything to the left. Questions so far? So if you think about what would have happened if I had left it. So if I had left this and I would have left this. Does this graph pass my function test? My vertical line test? No. And the f of x is saying this is a function, so there's something wrong with my drawing. If when you erase the part that you need to erase, it fails your vertical line test, you did something wrong, okay? There can be no x with a different y. This one has an overlapping one, so it's okay, right? That 3 got overlapped. But this would pass my vertical line test. Okay, so that's one method to doing it. The other way, and I would say when you use lines, it's probably easier to do what we did. But when we get to other graphs, when we get to things like square roots and parabolas and absolute values where you're not exactly sure where those points are, that maybe I would use the method I'm about to show you. This is plugging in points, but I'm going to plug in points specific to the range that they give me. So if I want to do the first graph, if I want to look at y equals 2x plus 3, and I want it to be true for the x values that are less than 0, I have to start at 0, but I'm going to put an open dot there. So my first point I'm going to plot is 0. And then I want to go less than 0, which means -1, -2, and so on and so forth if I need more points, okay? I'm going to plug those values into the first one. So 2 times 0 is 0 plus 3, 3. 2 times -1, -2 plus 3, 1. 2 times -2, -4 plus 3, -1. And then I'm plotting these points. 0, 3, which is going to get an open dot. -1, 1. And -2, -1. And I would know it would continue in that way. All right, then the next one is y equals 3 minus x. This time it's greater than or equal to 0. So for those ones, I'm going to start with 0, but I'm going greater than 0. So I plug in 0, 1, 2, okay? Do 3 minus 0, which is 3, 3 minus 1, which is 2, and 3 minus 2, which is 1. And then I plot those points. 0, 3, this time it's a solid dot. 1, 2, and 2, 1. Same graph, different process. You choose. I don't care which way you do it as long as you know how to do it correctly. Questions on either method? All right, so you could have chosen to plot your points, or you could have chosen to draw it out and erase it. I actually probably would do a combination of both for this one. So for my line, I'm going to draw it and then erase it, and then for the other one, I'll show you, I'll plot the points, okay? So for f of x equals 2x plus 1, I would start at positive 1, and then my slope is up 2 and over 1 or down 2 and left 1. And then I would draw the line, And then I would see that this should only be true for where x is less than or equal to -1, which means it's going to get a solid dot at -1 where it is, and it's going to go less than, which is left of that, and all of this is going to get erased. With me so far? Okay, so then the second one is now a parabola, which I know because I remember my parent functions, but we haven't even talked about them yet. We'll spend time there next section. But let's say I don't know for sure where this is going or exact points, right? This is where you can plot some points. So I would pick -1, but I'm going to remind myself that that has to be an open dot. And then I need it to be greater than -1, which means I'm going to go 0, and then I'm going to go 1. I plug in -1. -1 squared minus 3 is 1 minus 3, which is -2. 0 squared minus 3 is -3. And 1 squared minus 3 is -2. So my first dot, again, is not or equal to, which means it's an open dot. -1, -2, open dot. 0, -3, solid dot. 1, -2, solid dot. And I know it's a parabola, so the right side of my graph is going to do something like that. Vicky. So this one is greater than, and this one's greater than or equal to. The or equal to is the one that gets the solid dot. The non is going to be an open dot. If they were both open dots, it'd fail your vertical line test. So think about that and try to catch it if that happens.
Wait, which one were you doing the point for just now?
The point was for the blue one on the bottom, the parabola. Yeah, so if I was plotting points from the y equals, I would make it a solid dot for the first one. Yeah. So on your homework, when you get to web assign for this, it's that graph again. Don't stress out about trying to get it done on this graph, especially when you get to parabolas. Take it into Notability and graph on Notability, okay? I'm going to look at your graphs in Notability. On your test, you're going to have to do it by hand. So I'd rather you get used to doing it by hand than trying to do it on a complicated flash required thing on your iPad, okay? Questions? Yep.
So we have to use -1, or can we use different points?
If you don't use -1, you won't have the point in which it should end. That's that open dot. So I would say you have to use the one where the cutoff is, but the rest of them you could have done anything you wanted. Like I could have gone from -1 to 2 if I wanted to. But you have to have use these as your guide.
Okay.
So if it says -1's your cutoff, plug in -1. If it said it had to be greater than or equal to 0, use 0. Does that make sense?
Mm-hmm.
Okay, because you want to know where it's happening. You want to know what that end behavior is. Okay, even and odd functions. So there's two ways to determine if something is an even or an odd function, and that is first, algebraically. If a function is even, when for each x in the domain of f of -1 equals f of x. I'm sorry, f of -x equals f of x. In plain English, that means if I take a -x and I plug it in, it goes back positive. When else do we use that?
Squared.
That's when it's going to happen, right? If it's squared, if it's raised to an even power, or an absolute value. But what else do we use to test that? Symmetry. So this would be the same thing as y-axis symmetry, which you'll see on the next slide. This is the same test as y-axis symmetry. The difference is its function notation. That's it. F of x is y. So if I take a -x and plug it in, it goes back positive, then it's even. And then a function is odd when for each x in the domain of f of -x results in a negative f of x or a negative y, which is the same test for origin. It's just that instead of using the letter y, we use f of x. So if it's symmetric to the origin, then it's odd. If it's symmetric to the y, then it's even. From a graph, it's exactly what I just said. So if a function is even, then the graph is going to be symmetric to the y-axis. So I could fold it along the y-axis and it would overlap like a parabola, okay? Or a circle, or an absolute value. If I fold it along the y-axis, then it is even. And a function is odd when the graph is symmetric in respect to the origin. So this time, if I fold forward and left, it would overlap. Or if you fold it along your y equals x or y equals negative x line. So diagonally this way or this way. But in my head, I like fold it down and over. And if it overlaps, then it's symmetric to the origin. All right, so I'm going to even add to this, but this kind of puts a couple of things together. Graph the function, determine A, if the function is even and odd. B, the intervals for which f of x is greater than or equal to 0. And then I'm going to add in here to find the roots, because that'll help you. And increasing, decreasing behavior. And then use the graphing utility to verify. So which means I'm going to graph it by hand first, okay? So what do we know this graph is? It's a parabola. In about 4 days, you're going to know that that means that it is facing down and the y-intercept is at 4. But let's pretend we don't know that yet. We're going to plug in some points, okay? So because you want to find the roots, the easiest ones to plug in are what? 0. So I'm going to plug in 0 for y to get the roots. 0 equals 4 minus x squared. I can either factor this into the difference of two squares or add the x squared square root, making sure I do plus and minus. And I get that when y is 0, x is negative 2 and positive 2. Those are my roots. Though negative 2, positive 2 would be the solution. Those are the zeros, and those are the x-intercepts. So they double as all that. And then let's say I want to find the y-intercept. I'm going to plug 0 in for x. So f of x, same thing as y. 4 minus 0 squared, which is 4. So if you have enough information from those points to graph your graph, go for it. If you don't, plug in some extra points. Is this graph even or odd? It's even. Why?
Symmetric over the y-axis.
Good. Symmetric over the y-axis. I can fold this in half and it's going to overlap vertically, right? Or I could take a negative x and plug it in there. Negative x squared is going to go back to positive x. So my equation goes unchanged. You could check it either way. Is it odd? Can it be even and odd? Can a graph be even and odd? Can it have y-axis symmetry and origin symmetry?
Yeah.
Sure, right? A circle, gonna have all of it. So it is possible for it to be both, and it's possible for it to be neither, okay? There's no combination that doesn't work. So this one is even, okay? And then the next part says, find which intervals f of x is greater than or equal to 0. So let's talk about what that means. F of x is the same thing as y. So where on any graph is your y greater than 0? On the top part of my x-axis. Yes, all of this would be where y is greater than 0. Do we agree on that? Yeah. So how am I going to show the value specifically for this graph? The values of x for which it goes above or equal to that x-axis. Interval notation. So what's the interval for which it goes bigger than 0? You're right. Negative 2 to positive 2. And it gets a bracket simply because this says or equal to. If it just said greater than, I'd have a parentheses. But because it's asking for where it's greater than or equal to, it gets a bracket. What if it had asked if it was, where is it less than 0? What would that interval look like? How would I describe these x's?
Negative infinity to negative 2, and then positive 2 is infinity.
Does that make sense? Yeah. So it can be on more than one interval. You can separate it. If that's the case, you put that little u between it. Okay, that's how we show interval notation. Everybody good? Yes? Okay, last thing is increasing, decreasing. So again, even though it says increasing, decreasing behavior, if there's a constant part, I include it. Okay? Does this graph have any constant parts, any horizontal lines? No. So if I'm moving from left to right, what is it doing first? Increasing. So it's increasing from negative infinity. What's the x value in which it changes direction? 0. And then it changes so that it is decreasing from 0 to positive infinity. Does my 0 get a bracket or parentheses? Parentheses. Increasing, decreasing never gets a bracket. Only if your graph starts or stops constant can you even use a bracket, and it will only be on the constant part. Questions. So on your test, which is like a week from Tuesday, you are going to see a question something like this in which you cannot graph by hand. You'll have to use a graphing calculator and then answer the questions based on it. So make sure you're starting to get comfortable one. Okay.